Hello, good afternoon, everyone.
Good afternoon, sir.
Good afternoon, sir.
Good
Good
afternoon, sir.
afternoon, sir.
So today you had your two lectures, now. Okay, can you see my screen?
Yes, sir.
Okay, good.
Uh,
How many students were there in the previous lecture? Currently, it is showing me
Around 36 to 37.
36 to 37. Okay, okay. Okay, Richa, you have asked me the number of Rathod.
Suryajit Singh Rathod, sir. Yes, sir.
Yes, yes. I have actually, I am also not aware. I mean, I don't know his number. Somebody will be sending me soon his number, and then I'll pass on this number to you.
Okay, sir.
Okay. Now, first of all, welcome to SEM 2. And I hope you all did well in your exams in SEM 1. In just like in SEM 1, we have 4 papers and people are waiting in the lobby. Okay. And the paper number 410 is your analytical chemistry paper, and again I'll be taking up the first 2 units, and the other 2, third and fourth, will be taken by Mishra ma'am. In the first sem we had learned about some statistical analysis in tools in analytical sciences to apply statistics to our results, and these were the things which we studied: how to report our results and what should be the degree of uncertainty in our results, how can we find out the errors, etc. Now in this semester there are 2 units. The first unit is regarding sampling and sample preparation techniques, and the second unit which I'll be taking is that on chromatography. Now, uh, in any chemical analysis, what we are interested in is to analyze any substance in any form available to be analyzed by any known analytical tool or technique. And for that to be realized, we need to have a proper sample. When we talk about sample, we are not talking about the simulated samples or the samples which we prepare in our labs. We're talking about real samples. How can we analyze real samples using the known techniques which we have? But before doing that, we need to create, convert the real sample into a form which can be readily analyzed by the known techniques which we have in analytical science. Now, sampling and sample preparation have a special place in analysis, basically because uh, if the sampling is not proper or the sample preparation is not correct, then the desired results may not be obtained using any known technique. See, instrument, when we look at an instrument, as I said earlier as well, that it's a lifeless object, and we need to make it understand that what it is supposed to analyze. So for that we need to condition it, and for that we need to provide it a sample uh, which can give some response, and that to a reproducible response from that instrument, which could be relied upon, trusted upon. So the main bottleneck in any type of analysis with any form of a sample is the sampling process and the sample preparation. These are the two terms with which this entire unit will be dealing with. At the same time, the next point here is general steps in chemical analysis. We cannot be very specific in a unit here. That is why we'll understand the outline of the chemical analysis which we undertake and the different steps which we adopt in a successful chemical analysis. I mean, how we should go about any chemical analysis. And then we have certain techniques through which we can prepare a sample in a suitable form. And for that we have liquid extraction, we have liquid extraction or solvent extraction, then we have solid phase extraction, we have Craig's countercurrent extraction, hybrid solid phase extraction, solid phase micro extraction, accelerated extraction, microwave assisted extraction, and protein precipitation. These are some of the common techniques which are used for sample preparation, not for sampling. For sampling, we have a different set of tools here or methodology for sampling any real sample. Now, if you just look at first of all the sampling part, see, what we find in nature is we find real samples in principally three forms. It can be a solid, it can be a liquid, or it can be a gas. These are the three principal forms in which we find real samples in the universe. Now, which sampling procedure needs to be adopted? That depends upon the sample itself, in the sense that we know now that solids are the most heterogeneous samples. And we look at liquids, they are less heterogeneous, and gases are inherently homogeneous in nature. So depending upon the nature or the form of the real sample, we need to have a proper sampling methodology. Sampling methodology should be such that when we collect a sample from a bulk sample, from a large amount of sample, that small sample which we collect should be a true representative of the entire bulk which we have with us. That is very essential. Otherwise, the whole purpose of sampling gets defeated. So this is one major point which needs to be understood and analyzed. Say, for example, uh, uh, you are in the process of collecting a soil sample. Fine. Now you find soil all around. So you need to define certain things before you collect a sample. You can collect a sample from the topsoil, or you can go down and at a depth you can collect a sample of soil. You can collect a soil sample from a place where there is human habitat, or there can be a place which does not have, for example, any habitat, no traffic, nothing, very non-polluted area kind of a thing. So the composition of the soils would vary. So we need to consider all these things in the backdrop when we collect a sample. At the same time, the time when we collect a particular sample, uh, it could be the morning time, it could be evening, afternoon, it could be night. At the same time, it could be in the month of, say, January, or it can be in the month of May. So because of this environmental conditions as well, the nature of sample might change. So for that, we need to have a proper sampling methodology for any type of sample, real sample which we collect from for analysis. Now, if I just go through this, what it tells us is sampling and sample preparation are the most critical steps in the success of a chemical analysis. Because if the sampling is not proper or the sample preparation is not correct, then instrument has very little to do. I mean, it will respond according to whatever has been put into it. So if this is fine, possibly the analysis would also be fine. Many analytical problems begin with objects that are not suitable for laboratory experiments. See, for example, what is written here is that your real sample could be a water sample. Now, water samples, again, you have different kinds of water available in this universe. So because they have different matrices. So again, it is a one type of sample. The others could be like rock, a sample of a rock, or an alloy or an ore. It could be something like human biological fluids, which could be a blood, it could be plasma, urine, it could be even tissues. So there are varied types of samples which we need to analyze, and for that we need to have a proper setup for sampling and sample preparation. To perform a meaningful chemical analysis, we must obtain a small homogeneous sample whose composition is representative of the larger sample. This is very important because when we analyze something, it should be in the highest homogeneous form. So when we go to collect a small amount of sample, it should be homogeneous as much as possible, in the sense that it is a true representative. It is a true representative of the entire bulk. Sampling involves obtaining a small mass of a material whose composition accurately represents the bulk of the material being sampled. Again, the same thing is emphasized here, that in sampling what we do is we collect a small amount of sample. We collect a small amount of sample from a large amount of sample available. But the composition, when you analyze it, the composition of that small amount of sample should resemble the composition of the entire bulk which was available from wherever we have obtained that sample. That is the whole essence of sampling. See, there are different ways to sample solids. There are different ways to sample liquids and gases. I would this unit would not allow me to touch each and every aspect of sampling specifically when we go to collect a sample, because as I said, most of the things keep on changing, but there are definite guidelines to handle solid samples, liquid samples, and gaseous samples. So those procedures are well documented now with us when we go to collect a sample. Of course, taking into consideration, 1 minute, somebody is waiting. Dharmesh guest. I don't know whether he is. Okay, I'll just allow him. Okay. Now, as we understood that sampling is a process of selecting a representative bulk sample from the lot. A lot means, lot means a lot of sample which is available. So it's a bigger lot, and from that we need to collect a small amount of sample. And this process of collecting, this entire process of collecting, how to collect, how to define that sample. Because when I say how to define that sample, you need to define from where have you collected, at what time you have collected, how much you have collected, from what depth you have collected. Those are the things which one needs to, plus what is the surrounding environment there. Because otherwise what will happen, soil is a soil. So if you say we have found this much amount of this present in a given soil sample, it has no meaning. But when we say that this was the soil sample, the origin, the history of the soil, and then what we obtained was this. These were the constituents which are present in that soil sample. So that holds some significance. And then, of course, when you write your results, you apply statistics to it. So sampling is a process of selecting a representative bulk sample from the lot. ज्यादा में से जो ज्यादा सैंपल होता है उसमें से कुछ थोड़ी सी चीज ले लेना which exactly resembles the entire bulk, that is sampling. From a representative bulk sample, a smaller homogeneous laboratory sample is obtained by undergoing certain processes. That means, as I said earlier, we need a homogeneous sample for analysis. This is a prerequisite. We need a homogeneous sample for laboratory analysis, for analysis using a suitable technique or a tool. But we need a very small amount of sample. So from the representative bulk sample, once we have collected, we need to prepare a homogeneous laboratory sample is obtained by doing a process such as grinding it into a fine powder, maybe mixing. There could be a process called maybe distillation. It might involve digestion with perhaps acids, or fusion with some alkalis, maybe digestion it may require a process called derivatization. So these are the things which we do with a sample which we have collected from a lot, such that it becomes a homogeneous sample, and homogeneous sample that could be analyzed by an instrument, because instrument works on a principle. So we need to give it the instrument, we need to give that sample in a form that it starts to recognize what we want from that sample. That is what sample preparation is. And once we have prepared a solution, a laboratory sample solution for the given sample, we take very small test portions, जिसको हम कहते हैं aliquots. We call it an alicot. Alicot means जो छोटा सा sample है, which can be directly used for analysis. Now, no more further processing of that sample is required. We have collected a highly homogeneous laboratory sample by following any of the known process. It could be, as I said, it could be grinding, mixing. Grinding could be in a grinding mill, or it could be in mortar pestle, or it could be dilution, it could be digestion, it could be distillation. Any of these processes once we do with the sample, and then we finally collect a sample, a small test portion, और उसमें से हम थोड़ा सा ले लेते हैं directly, which can be subjected to analysis in an instrument. That is known as an alicot. And when we look at sample preparation, there are a few other things as well which we need to consider. See, the most bothering thing in chemical analysis is converting that sample into a form which can be readily analyzed by that instrument. And what is the major problem when we work with real samples is that real samples have different matrices. It is very different from the way in which we work in our labs. Unfortunately, the way we teach you about real samples. But when we ask you to do any experiment in the lab, we always give you a sample whose composition is known, or a simulated sample. So things are much easier to work with when we work in our labs, and therefore we are unable to realize how much effort needs to be put in to analyze a real sample. One of the major problems is the matrix, the substances which are present in that sample, which may interfere with analysis. That means interfering substances that can cause some sort of error in analysis in the real samples is a major bottleneck in sample preparation and subsequent analysis. So जब भी हम कोई काम, जब हम सैंपल प्रिपरेशन करते हैं किसी भी सैंपल की, तो सबसे इम्पॉर्टेंट चीज़ है कि हम उसको सही तरीके से होमोजीनियस फॉर्म में ले आएँ, और ये भी इंश्योर करें कि उसमें जितने इंटरफेरिंग सब्सटेंसेस हैं वो उसमें से निकल जाए, सो दैट हम सैंपल को लेके डायरेक्ट एनालिसिस कर लें. अदरवाइज direct analysis using an instrument is not possible. And I'll be showing you one example from where we can understand what needs to be done to remove these interfering substances. So these interfering substances can be either removed before analysis. It can be either removed, or they can be converted into their inactive forms. That means they do not take part in the analysis. These are the two ways in which we can manage our interfering substances which are present. Interfering substances means the entire matrix. Anything out of that matrix might interfere analysis of the desired analyte. So this is one major, thing which bothers in chemical analysis, and therefore you find several, methods available in literature, even for solids, even for liquids, and even for gases. The only reason behind having so many, methods available is because the composition of matrix changes from sample to sample. So when the composition changes, the presence or absence of interfering substances is always there. Their concentration is also a problem. So we need to remove this before we move on to actual analysis using an instrument. Now this is what the entire thing is represented in this form. You have a lot means you have a large amount of sample in front of you, and then you take a small amount of sample, of course by defining that sample, and in such a way that it is a true representative of the entire bulk or the entire lot of the sample which was available to you, the real sample. And then once you have obtained a representative bulk sample, you do some processes such that it can be readily analyzed by a technique or an instrument. And this process is known as sample preparation. So you try to prepare a homogeneous lab solution or a sample. And once you have prepared a homogeneous sample, then you take a suitable aliquot. A small volume which could be directly used for analysis. But the main concern here is in this entire process, once we have done an efficient sampling, the problem during sample preparation is, as it is mentioned here, that we need to remove or mask the interference of any substance other than the analyte of interest. Now, if you can just look at this example here, we have determined calcium and magnesium in water. There was an experiment using EDTA, a simple EDTA titration. Now, this is the gap in which we work with as far as theory is concerned and as far as practical is concerned. What you did was you simply added buffer solution, you added hydrochrome black tea, and you started the titration. You are not worried about any of the interfering substances which might be present. The reason was this was a prepared solution. This was a simulated solution sample which you analyze. So you were not told to remove this or that before analysis. It was not a real sample. But when we work with a real sample, it is known that if aluminium is present in that water sample, it also reacts with EDTA. If that also reacts, naturally, you will be getting an enhanced reading for calcium. If you think you are titrating calcium, and if that sample contains aluminium as well, so आपको reading ज़्यादा आएगा. So in such a case, you can do again two things. Either you remove aluminium from that solution. If you remove that aluminium from solution, then it is fine. But if you cannot, then in that case, you need to convert it into a form which is inactive, which does not take part in the reaction with EDTA when calcium reacts with EDTA. And that is where we add a masking agent such as sodium fluoride, which reacts with aluminium to form AlF6. And once that is formed, it does not enter into the reaction with EDTA. and hence it is possible to determine calcium in water sample using EDTA. But this was not known to you. This was not told to you during when you did your experiment. So in such a way, all such practicals which you have been taught have been so very optimized, and when you are always working with only simulated samples, prepared samples, that these things we are unaware of and they don't bother us. But when you work with real samples, these are the things which we need to look at. Otherwise, see, if determining calcium magnesium is that simple in water sample, anyone, you don't need to uh, go to do post graduation to do a calcium magnesium titration. But the major thing which people may not be knowing is that under the presence of which ions you cannot directly titrate calcium with EDTA. That is important. And for real samples, we are not aware of कि उसमें aluminum है या नहीं है. So for that, we can do some qualitative tests to ascertain the presence or absence of aluminium. Or what we can do is you can always you can find out the presence of aluminium or any other interfering ion which is present by you can titrate a calcium solution separately, pure calcium solution, and then you add small amount of aluminium to it and then do the titration. If you get a higher reading in presence of aluminium, you can always come to know that yes, in the presence of aluminium, it reacts with aluminium as well. Because when you see, when you take a mixture of calcium and magnesium and you add a buffer and your indicator, it is not that EDT reacts with only calcium. It reacts with magnesium as well. So in the first part, you get combined reading for calcium and magnesium. And then in the second part, you try to mask the interference of magnesium ion. How? By adding an alkali, by forming a hydroxide of magnesium, and thereby it does not enter in the reaction with EDTA. And hence you find only the calcium ion. Say for example, by mistake, if you have added more amount of 4 normal NaOH, what will happen? Even calcium will also get precipitated. And if that happens, you will not get the endpoint for a sample which contains calcium and magnesium, which you have prepared in the lab on your own. So for each and every such titration or a simple reaction, in real samples when we work with, we need to be very careful with anything which is present other than this, and that can be ascertained, as I said, by doing some prior qualitative tests. That is why that becomes very very essential. अच्छा, अभी तक आपको ये चीज समझ में आ रही है, सैम्पलिंग एंड सैम्पल प्रिपरेशन?
Yes, sir.
I'll just see how many are present. Richa, do you follow? Sunil?
Yes, sir.
Okay. Jackishan is there? Okay. There are only 44. Okay. So what if it is fine now, matlab, should I be more bilingual or I should be speaking more in Hindi or Gujarati, or it is okay?
It is okay, sir.
It is okay now. Okay. Matlab, just keep me, just reminding me, remind me in between if you feel कि कोई चीज समझ में नहीं आ रही है. See, this subject, this topic is uh, possibly you will appreciate more when you actually work with the real samples. Since you do not work with real samples, you don't understand the gravity of sampling and sample preparation, because we give you samples which are ready to use samples for analysis. So one never bothers, and that is very obvious, and we don't know what actually is happening. See, this is where the things become difficult in analysis. Otherwise, if you go to literature, you have hundreds of procedures, methods, you have hundred of techniques available, and you can use them directly. But unfortunately, the sample is different. And once the sample is different, uh, that existing, known, established, optimized procedure might not work with your sample. And that is where the work of analyst comes in. With his knowledge, with his experience, he can modify existing methods or develop new methods which are suitable for his or her sample, a specific sample. So see, as such, as I said, sampling of liquids, solids and gases, there are guidelines. There are definite guidelines for sampling solids and liquids and gases separately, which this information, detailed information, I mean, it is beyond the scope of any unit. But you do not worry about that because this can be dealt with in greater detail when we are actually working with real samples. Since we do not give you such samples, I think at this point of time it may not be of interest to you. So what I have done here is I have restricted myself to only those things which are more important and more relevant to you as a student in understanding and appreciating the sampling and the sample preparation. Sample preparation is a process, sample preparation, such that your final sample, prepared sample or aliquot, can be directly analyzed. And for that to be realized, there are certain methods, certain tools, and that is what is covered in this unit. So there is less emphasis on sampling, but more emphasis on sample preparation. Okay, moving ahead. Now, the following slides will give us an idea about uh, few general steps. We cannot have specific steps here because it all depends upon a particular sample. So we have a few general steps in chemical analysis which will help us in devising a strategy to analyze any sample in any form. That is what is intended here uh, uh, in showing you some general steps. See, the first step is formulating a question for a given sample. What does that mean? इसका मतलब ये है कि अगर आपके पास कोई एक सैंपल लेके आता है, से फॉर एग्जांपल एक लिक्विड सैंपल लाता है, we can make things little simple by taking a liquid sample. So और वो ये आपसे कहता है कि ये बॉटल में एक सैंपल है, लिक्विड सैंपल है, और इसकी मुझे एनालिसिस करके दो. So his problem is that he wants to get that sample analyzed by you. Now it is a liquid. You find thousands and thousands of liquid as a sample for analysis. So now what will be your thinking? You will ask or formulate some questions, and then you will seek some answers. And based on those questions and subsequent answers, you will devise a strategy to select a particular procedure or a modified procedure, a particular tool for analysis. So जैसे कोई एक सैंपल लेके आया तो आप उससे ये पूछोगे कि ये सैंपल लिक्विड है, कहाँ से लाए हो, किस चीज का सैंपल है. अब लिक्विड तो ऑयल सैंपल भी हो सकता है. It could be aqueous based, it could be organic solvent based. So these are certain questions which we are going to ask. If he says that it is totally aqueous sample, which clearly means that it contains possibly ionic substance, because ionic substances are soluble in aqueous phase, which is a polar solvent. So presence of bulky organic groups or molecules, the possibility of those is very less. So what you are trying to do in your mind in devising the strategy is you are trying to narrow down on certain aspects. If it says that it is an oil sample, so definitely you will ask about what is the possible oil in this sample. What is the possible oil in this sample? From that oil sample, you will come to know, if it is a homogeneous sample, you will come to know that it is a hydrophobic sample, possibly because it is highly soluble in an oil sample or a non-aqueous solvent, for example. So, plus you will come to know through certain tests that how many components are present in that sample. So you are going to ask him several questions, and based on which you will find out your own answers through your experience and knowledge, and then devise a strategy for analysis. You will also find out whether it is an aromatic compound or an aliphatic compound. If it contains ionic compounds, then you can do several chemical tests to ascertain their presence or absence in that. So you need to narrow down, you need to come down to make that whole thing more specific rather than general, which is for the specific sample. The next step is selecting analytical procedures. Now, when you look at the chemical literature available or analytical literature available, you will find hundreds and thousands of procedures which are available to analyze, for example, aqueous samples or non-aqueous samples. So what will you think of depending upon the probable things which are present, depending upon the likely concentration of those constituents which are present in that sample. You will narrow down on a suitable analytical procedure or a process which you can follow to make a proper sample. So you will always think of a suitable procedure available in literature, or of course you are free to modify that procedure based on your experience and knowledge so that it becomes more suitable for the sample at hand. The third thing is, again, as I said, sampling and sample preparation. See, that sample which was given to you, it cannot be used directly as such. It cannot be used directly because you need to ascertain when you go to analyze A, B in a given sample, you need to find out whether the C, D, E, F, which are also present, should not interfere with the analyte of interest. They should not interfere with the analyte of interest. So you need to have a suitable sample preparation technique as well which will help you in removing the interference of CD, for example, or mask their interference if you are unable to remove that from the sample. Of course, you need to make it homogeneous before you do your sample preparation, etc. And then you can see whether the form which you want to analyze can be done, or if it can be done directly, or your method requires it to be derivatized. So you can derivatize your analyte of interest. If you are unable to remove the interferences, so once it is derivatized, it takes a different form. And once it takes a different form, the instrument starts to recognize that form. And therefore, it helps you in the analysis. Again, sample preparation is also concerned about what is the concentration of that analyte is present in that sample. So you need to be very cautious about the concentration as well. Because even if we have prepared a sample, say for example, if the concentration is very, very low, if it is very low, and when you look at the instruments available, this might not work. Because the sensitivity of that instrument is not to that extent that it can detect that low concentration of analyte. So in such a case, you need to pre-concentrate it. That means you need to increase the concentration. If it is higher concentration, it becomes easier to simply dilute. But when it is very low concentration, you need to pre-concentrate. So when you pre-concentrate, you need different techniques. And for that, we have several techniques now in our syllabus in this unit, which help us in pre-concentrating as well. That means removing unwanted, at the same time pre-concentrating or increasing the concentration of those analytes such that they can be readily analyzed by your analytical technique. Then comes your analysis. See, analysis part becomes much easier, much simpler if the sampling is good, if the sample preparation is correct. Analysis becomes then relatively simple. क्यों सिंपल हो जाता है? क्योंकि अब हमें मालूम है कि हमारे सैंपल में जो हम चाहते हैं वही है और कुछ नहीं है, और है भी तो वो इनएक्टिव है. So instrument also recognizes that very well. Okay, and it starts to respond reproducibly. This is very important. Matlab, it starts to respond linearly, proportionately with respect to concentration. So analysis part, of course, then you can always ascertain by replicate measurements. This is a very essential part, as we know, which we understood in semester 1, that एक sample analyze करने से कुछ नहीं होता. You need to have multiple samples, replicates of that same sample to ascertain whatever you are getting is correct or not. And that is why I emphasized earlier as well that when you analyze real samples, precision becomes very important. Because accuracy तो वो होती है कि हम कितने accurate हैं, लेकिन वो तो हमें पता ही नहीं. तो जो चीज़ हमें पता ही नहीं है उसमें है कितनी. So we should not worry too much about it, but at least we should worry first of all about the degree of reproducibility which we have in replicate measurements. So once we are through with that, then we can look for the accuracy. And for accuracy, what we can do is we can use 2-3 different methods, 2-3 different techniques, and see whether we are getting the same result. If we still get the same result, then we say that yes, our results are precise, yes, at the same time they are accurate as well. So possibly this would be the true value or close to true value. And then we apply statistics and then say that the true value lies between this. And then we report our results. So that is a very important aspect of analysis that you do, replicate analysis, to understand the extent of reproducibility in your measurements. And then the sixth and seventh point is reporting, interpretation, and of course drawing some logical conclusions from your analysis. Reporting is fine. See, there is a definite protocol under which one is supposed to write or report the results which you obtain in your analysis. It is something which is a set protocol, that this is the format in which you are supposed to write, of course, by applying proper statistical tools. And then you can always interpret as well, but interpret as well uh, so that it will be more useful to the concerned person who has given you the sample. Interpretation means कि अगर कोई चीज, or drawing conclusions, is that once you get a result following all these procedures and methods, next step is ये एक चीज कम है या ज्यादा है, ये कम क्यों है या कम क्यों ज्यादा है, या ये एब्सेंट है, ये एब्सेंट नहीं होनी चाहिए थी. These things could be a part of chemical analysis when we report any result. कि ये कम है, अगर ये कम है तो ये सैंपल की efficiency कम है. मतलब if it is to be used for a particular purpose, you need to increase the concentration of this. Then it would serve the purpose. So you can always suggest or draw some conclusions when you write your result finally, that if you can add this or you can remove this from your given sample, the efficiency of your sample is likely to increase. And these are the conclusions which one can draw and submit to the concerned person. ये इतनी चीज समझ में आ रही है?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay. Good. Good. So these were the 7, general common steps which are being employed when we analyze any sample in any form, the real sample in any form, for which we do not have any solid information. We collect information, we devise a strategy, we formulate our own questions, and then we arrive at possible answers, and then we go to the literature and look at the methods available, procedures available, instruments which have been used in a similar kind of analysis, and then we modify as required, and then we arrive at some analysis, the results, and then we check it through replicate analysis, and then we check it through different procedures based on which we arrive at the accuracy and precision, and then of course we can submit possible conclusions which one can draw from those analysis. Now, this is one such technique, extraction technique, which we have already studied possibly in third year BSc, that is solvent extraction, or also called as liquid extraction. Now I'll just be very brief in this because almost it is 5 o'clock. Just 2-3 minutes on solvent extraction and liquid extraction. I'll just give you an idea about when we talk about so many techniques and methods in chemical analysis. I like to bring forth in front of you few things which are currently more researched upon, and those are जैसे फॉर एग्जांपल आप सोचते हो कि ये सब टेक्निक्स आपको पढ़ाई जा रही हैं अभी, ये काफ़ी पुरानी टेक्निक है और इसका पर्पस है कि हम कुछ अनवांटेड चीज़ सैंपल में से निकाल दें या फिर हम जो हमारा एनालाइट है उसका कॉन्सेंट्रेशन बढ़ा दें, यानी प्री कॉन्सेंट्रेशन. सो दिस टेक्निक सर्व्स ड्यूअल पर्पस और इसको हम करते आए हैं एक सेपरेटरी फनल में, और हम सब ने सेपरेटरी फनल देखी है. बड़ा सिंपल सा ये एक प्रोसेस है, लेकिन हमने इसको एक बड़ी बड़ी 50-60 ml की ये सेपरेटरी फनल होती है, इस पर सबने काम किया होता है और इसमें बहुत सारा सॉल्वेंट भी यूज होता है. तो अब क्या है, ये जितनी भी टेक्निक्स हम आप पढ़ रहे हैं, अब जो रिसर्च हो रही है एनालिटिकल साइंस में, वो 5 एरियाज में हो रही है. फर्स्ट एरिया ये है कि इन द एरिया ऑफ मिनिचराइजेशन, मतलब हम हर टेक्निक को, हर टूल को छोटा बना रहे हैं. इंस्ट्रूमेंट पहले इतने बड़े बड़े आते थे, अब हमने इतने छोटे छोटे कर दिए, टेबल टॉप बनाना शुरू कर दिया. हम लिक्विड एक्सट्रैक्शन पहले 50-60 ml से करते थे, अब वही चीज हम 2 to 3 ml में कर लेते हैं. सेम थिंग इज डन इन 2 to 3 ml. So we are in the process of making an equipment which is easily accessible and possibly easy to handle with less hassles, and it is very small, compact, so it can be kept anywhere. You don't require large space there anywhere, so it fits in a small space. So this is one area where now research is going on because we have so many methods etc. now available. The second area in which people are working is automation. Automation means हम जो मैनुअली काम करते हैं ना, लिक्विड एक्सट्रैक्शन में मैनुअली करते हैं. We shake it by take it in our hand and then we shake it and then we keep it for separation, phase separation. अब ये सारा काम ऑटोमेटिकली होता है. आपको वो छोटी सी वायल के अंदर 2 से 3 ml की वायल को भर के रख देना है 10 मिनट्स तक. 10 मिनट्स के बाद निकालना है. वही काम हो जाएगा जो आप 50 ml को एक बड़ी सेपरेटरी फनल में 15 मिनट तक शेक करते थे. वही काम उससे भी ज्यादा हायर एफिशिएंसी के साथ आप ऑटोमेटेड चीज में, ऑटोमेटेड सिस्टम के अंदर काम कर सकते हो. तो इंस्ट्रूमेंट्स आर ऑल्सो बीइंग मेड ऑटोमेटेड. दैट मीन्स उसमें कम से कम ह्यूमन इंटरवेंशन के साथ हम काम कर रहे हैं, वो एक एडवांटेज है. इसी तरीके से जो टूल्स हैं, जैसे ये सेपरेटरी फनल है, इसको भी हमने बहुत छोटा बना दिया है, मतलब स्मॉल साइज, सो दैट सॉल्वेंट का कम उपयोग हो, डिस्पोजल का प्रॉब्लम कम हो. ये सारी चीज़ों को भी हमने ध्यान रखा है ये चीज़ों में. तो मतलब ये दूसरा एरिया है. तीसरा एरिया ये है कि जहां हम अभी तक हम एक एक इंस्ट्रूमेंट में काम करते हैं. IR अलग, NMR अलग, मास अलग, क्रोमेटोग्राफी अलग, स्पेक्ट्रोफोटोमेट्री अलग. अब उन्होंने ये कहा कि अलग अलग से इसके सिवाय, अगर इसके बजाय अगर हम 2-2 या 3-3 इक्विपमेंट को साथ में मिला दें, हम हाइफनेट कर दें, हम इंटीग्रेट कर दें, तो हमें एक इंस्ट्रूमेंट से काफी सारी इंफॉर्मेशन एक समय में मिल सकती है. तो जो हम प्रोसेस अलग अलग स्टेजेस में करते हैं, अलग अलग लैब्स में करते हैं, उसको हम एक जगह कर सकते हैं. सो नाउ दिस इज द एज ऑफ हाइफिनेशन as far as analysis is concerned. So people have combined LC with MS, LC with NMR, LC with IR, then LC with SP, SPE with NMR with MS, CEE, capillary electrophoresis CE with MS, SFC, supercritical fluid chromatography with MS. The techniques which are combined are complementary in nature. मतलब सब टेक्निक अलग अलग इंफॉर्मेशन देती है, उनको कंबाइन कर देते हैं. इसमें चैलेंजेस हैं, बहुत चैलेंजेस हैं, बट पीपल हैव बीन वर्किंग ऑन इट. तो ये तीसरा पॉइंट है. चौथा पॉइंट है ग्रीन अप्रोच. हम चाहते हैं कि जो केमिकल्स यूज करते हैं वो टॉक्सिक होते हैं, तो उसके ऑल्टरनेट्स लिए जाएं. तो उसके लिए हम ऐसे ऐसे टूल्स, ऐसे ऐसे केमिकल्स यूज कर रहे हैं विच आर मच ग्रीनर, एनवायरमेंटल फ्रेंडली, लेस टॉक्सिक. सॉल्वेंट्स का उपयोग कम हो, इसलिए हम एक्वस में ज़्यादा रिएक्शन करना चाहते हैं, फिर आयनिक लिक्विड्स में हम रिएक्शन करना चाहते हैं। सो वो टॉक्सिक कम रहें और वोलेटाइल कम रहें, तो डिस्पोजल का प्रॉब्लम कम हो, तो वो कर रहे हैं। और पांचवी चीज जो है वो आर्टिफिशियल इंटेलिजेंस। दैट मीन्स इंस्ट्रूमेंट को ये पता चल जाएगा आपके काम करने के तरीके से कि आप उससे क्या इंफॉर्मेशन चाहते हो। दिस इज अ वेरी इंपॉर्टेंट एस्पेक्ट ऑफ एनालिसिस। जब आप से फॉर एग्जांपल आप कुछ जब टाइप करते हो कंप्यूटर पे, तो वो कभी आप देखते हो खुद ब खुद आने लगता है, आगे चल के कुछ आने लगता है, फिर उसको कहा जाता है टैप करो तो ये टाइप हो जाएगा ऑटोमेटिकली। So it knows the thing. There is an intelligence which knows that what you intend to do next, and that is what will be done by an instrument. There will be more intelligent instrument available, and they will be giving you answers rather than seeking answers. So they will be giving you some answers as well. तो ये जो 5 एरियाज मैंने बताए, जो एक है मिनिचराइजेशन मतलब छोटा कर देना, ऑटोमेशन, hyphenation, green approach, and artificial intelligence. These are the 5 areas where analytical science is moving towards. And जब हम ये टेक्निक पढ़ते हैं सॉल्ट एक्सट्रैक्शन या लिक्विड एक्सट्रैक्शन, तो इसको भी आज की तारीख में मिनिचराइज कर दिया गया है। तो ये चीज मुझे बतानी थी, एंड आई होप यू हैव अंडरस्टूड व्हाट आई वांटेड टू कन्वे। एंड आगे मैं कंटिन्यू करूंगा ऑन वेडनेसडे। यस, वेडनेसडे वी हैव अ लेक्चर, तो इसी को मैं आगे कंटिन्यू करूंगा विद सॉल्वेंट एक्सट्रैक्शन। इफ यू हैव एनीथिंग यू वांट टू आस्क, प्लीज। किसी को कुछ पूछना है? तुम लोग हो या चले गए? हेलो।
Yes, sir.
Hello, sir.
यस श्रेयांश, श्रेयांश।
Uh, Sir, is there any role of temperature and pressure in sample preparation or analysis?
यस, देखिए रोल ऑफ टेम्परेचर एंड प्रेशर, ऐसे मतलब जैसे आपने 2 फैक्टर्स गिनाया है, ऐसे बहुत सारे फैक्टर्स हैं जिनका रोल रहता है सैंपल प्रिपरेशन में। सी कभी कभी क्या होता है, जैसे मैं आपको बताऊं, हम लोग वी आर यूज्ड टू डाइजेस्टिंग सैंपल्स इन ओपन वेसल्स, बट देर आर samples in which if we do open digestion, for example, then some of the components get converted into volatile form, and they simply are, they are, the sample is devoid of this when you do actual analysis. So temperature तो है ही है, pressure भी है. There are different ways. I mean, the way in which we analyze a sample or prepare a sample for under sample preparation also determines कि इसमें जब हम एनालिसिस करते हैं, तो इसीलिए ये कहा जाता है कि सैंपल प्रिपरेशन अगर आपकी अच्छी है और सही है, इफिशिएंट है, तो रिजल्ट मिलने में इतनी प्रॉब्लम नहीं आती है, क्योंकि वी हैव डेडिकेटेड इंस्ट्रूमेंट्स अवेलेबल नाउ विद अस। सो सैंपल प्रिपरेशन में जैसे आपने कहा टेम्परेचर प्रेशर का रोल होता है, डेफिनेटली काफ़ी सारी जगह, काफ़ी सारे, व्हेन वी लुक गो इनटू द स्पेसिफिक्स of any particular sample preparation, we will understand the importance of temperature also, we will understand the importance of pressure also, because most of the things now is being done in closed vessels. कुछ चीजें इतनी टफ होती हैं कि वो नॉर्मल कन्वेंशनल सॉल्वेंट्स में डिसॉल्व नहीं हो पाती है, तो उसके लिए हम सुपर क्रिटिकल फ्लूइड्स लेते हैं, उसको एक्सट्रैक्ट करने के लिए हम अलग सेट ऑफ कंडीशंस लेते हैं, कंडीशंस ही अलग होती हैं. So there are many factors which ultimately determine the success or failure of any sample preparation. But as you said correctly, yes, they do affect. Anything else?
सर
यस कार्तिक।
सर एक एक्सटर्नल एग्जाम में एक क्वेश्चन था, तो मुझे उसके
हाँ।
बारे में पूछना है। सर उसमें एक
हम्म,
क्वेश्चन था कि विच टाइप ऑफ सैंपल इज वेरी हार्ड टू एनालिसिस, और ऑप्शन दिए गए थे सॉलिड, लिक्विड, सुपर क्रिटिकल और ऑल ऑफ दिस कुछ था, तो
हम्म,
उसमें क्या क्या हो सकता है?
सॉलिड्स।
सॉलिड। ओके।
यस। मैंने आपको ये, अगर आप लेक्चर में रहे होंगे तो मैंने आपको ये बताया भी था सेमेस्टर 1 में, सिंस दिस इज अ मोस्ट हेट्रोजीनियस इट इज वेरी टफ टू एनालाइज। सी, उसको मतलब उसका एक होमोजीनियस सैंपल बनाना एक हेट्रोजीनियस में से, हाईली हेट्रोजीनियस में से इज वेरी टफ। मतलब
ओके।
मैं ये कहता हूं कि एक बड़ा सा पत्थर पड़ा है, ठीक है, बहुत बड़ा एक रॉक सैंपल है, बहुत बड़ा। उसमें से मैं कहूंगा आपसे कि आप रॉक सैंपल का मुझे एनालिसिस करके दो, तो नेचुरली आप एक साइड में जाओगे, थोड़ा सा तोड़ोगे और उसके एनालिसिस कर लोगे। लेकिन आप ये नहीं बता सकते मेरे को कि अगर दूसरे तरफ से तुम जाते उसके और वहां से तोड़ते, तो वही तुमको मिलता है कॉन्स्टिट्यूएंट्स, और उतने ही मात्रा में मिलता है जितने तुमने दूसरे तरफ से तोड़े थे। मतलब इट इज वेरी डिफिकल्ट टू टू फर्स्ट टू डू सैम्पलिंग। पहली चीज सैम्पलिंग। तो जब ऐसा केस होता है ना, तब हम क्या करते हैं, अगर आपने मेरे से पूछा ये तो मैं आपको बताता हूं। हम डिफरेंट डिफरेंट प्लेसेस से तोड़ते हैं, फिर उसका एक पूल्ड सैंपल बनाते हैं। पूल्ड सैंपल मतलब कि सपोज हमने 5 जगह से लिया, ऊपर से, साइड से, नीचे से, इधर से, उधर से, सब जगह से लिया 5 डिफरेंट सैंपल्स। तुम अगर पांचों के एनालिसिस सेपरेटली करोगे ना, तो आपको सारे कॉन्स्टिट्यूएंट सेम अमाउंट में नहीं मिलेंगे। तो क्या किया जाता है, इसको अगर हमको हेट्रोजीनियस बनाना है और होमोजीनियस बनाना है, तो हम वो पांचों सैंपल को सेपरेटली भी एनालाइज करते हैं और बाद में इसका एक पूल्ड सैंपल बनाते हैं। मतलब सबको मिक्स कर देते हैं, मिक्स करते हैं, फिर उसको भी हम अच्छे से उसका यूनिफॉर्म पाउडर बना के उसकी एनालिसिस करते हैं। वो हमको ये बताएगा कि इतने हेट्रोजीनियस को भी हमने किस तरीके से होमोजीनियस बना के उसकी एनालिसिस की। लेकिन आपको बताना पड़ेगा कि आपने कहाँ कहाँ से सैंपल लिया, पहले वो डिफाइन करना होगा। सो दिस इज वेरी टफ। लिक्विड्स में तो क्या है, सब कुछ घूम रहा है, सब कुछ घूम रहा है। सो कुछ हद तक होमोजेनिटी अंदर डेवलप हो ही रही है। ऐसा नहीं कि पूरा होमोजीनियस है, बट टू अ ग्रेटर एक्सटेंट होमोजीनियस हो ही रहा है। तो इट इज लेस टफ। गैसेस में क्या है, टू अ ग्रेटर एक्सटेंट होमोजीनियस हो रहा है एट एनी गिवन पॉइंट ऑफ टाइम, टू अ ग्रेटर एक्सटेंट। So it is even simpler to analyze, not to hold that sample. I have not asked कि किसको पकड़ना आसान है, वो तो सॉलिड आसान है, लिक्विड तो हाथ में आता नहीं है, गैस भी हाथ में आती नहीं है, वो वाली बात नहीं है। टू एनालाइज। और जो सुपर क्रिटिकल फ्लूइड की बात की है, सुपर क्रिटिकल फ्लूइड तो देखो ऐसी चीज है, वो तो एक कंडीशन है, वो तो एक ऐसी लिख दिया था आपके ऑप्शन में। वो तो एक स्पेसिफिक टेम्परेचर एंड प्रेशर पे कुछ ऐसे सब्सटेंसेस हैं जिसको हम सुपर क्रिटिकल फ्लूइड में कन्वर्ट कर पाते हैं, और वो भी सबको नहीं कर पाते। जैसे CO2 है, पानी है, अमोनिया है, इनको लोगों ने सुपर क्रिटिकल फ्लूइड बना दिया इसका, लेकिन वो आपको कभी दिखेगा नहीं। लेकिन आप किसी एक जैसे फॉर एग्जांपल CO2 को अगर तुम 31 डिग्री सेंटीग्रेड और 72 एटमॉस्फेयर प्रेशर पे रखोगे, तो CO2 जो है नाइदर गैस होती है, नाइदर लिक्विड होती है, नाइदर सॉलिड होती है, वो चौथा स्टेट में चली जाती है। तो ये एक डिफरेंट स्टेट है, एंड दैट स्टेट इज होमोजीनियस। दैट स्टेट इज होमोजीनियस, बट it needs to be attained. It needs to be attained at a definite temperature and pressure. So the most difficult to work with for analysis is solids. Is
ओके
it
सर,
okay?
थैंक यू सर, यस यस।
Yes, good. Anything else which you want to ask? See, if you come across, if you come with such questions every time, what I feel is it will be more useful to you and others as well. Because मैं आपको आके सिर्फ पढ़ा दूं, 1 घंटा बोल दूं और आप सिर्फ सुन लो, आप सुनते हो, ये बात नहीं है, बट जब तक आप क्वेश्चंस नहीं पूछोगे, जब तक ये फैकल्टी अपनी नहीं खोलोगे, तब तक क्या है कि यू विल नॉट एंजॉय, आप बोर हो जाओगे। आज मुझे भी 3 घंटा कोई सुनाएगा कोई चीज बैठ के, तो मैं भी बोर हो जाऊंगा। लेकिन अगर मैं क्वेश्चंस पूछूंगा ना, तो मेरे को भी सीखने मिलेगा और औरों को भी सीखने मिलेगा। सो इट इज़ गुड कि आप लोग कुछ ऐसे जनरल क्वेश्चंस जिसके आंसर्स आप सीख करते हो, वो आप लेक्चर के दौरान या बाद में आप जरूर पूछते रहो मेरे से। ठीक है, if you have more, I am there, but if it is done, then thank you everyone. Stay safe until we meet again on Wednesday. Thank you.
Thank you, sir.
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 Great.
सर
Yes, yes. खुशबू?
सर वो
Yes.
आपने अभी बताया था ना कि अलग अलग मेथड्स को कंबाइन करते हैं, पर ऐसा कैसे हो सकता है सर? दोनों मेथड अलग अलग प्रिंसिपल्स पे काम करती है, फिर भी ऐसे हो सकता है?
तुम
कि दोनों
खुशबू
के
हो?
प्रिंसिपल
खुशबू?
एकदम डिफरेंट है ना सर?
बिल्कुल बिल्कुल बिल्कुल, यू आर खुशबू, राइट?
यस सर।
हाँ देव, जो तुमने मेरे से सवाल पूछा है ना, ये पहली चीज मैं बताऊं कि ये बहुत ही वैलिड सवाल है, बहुत ही इंटरेस्टिंग सवाल है। और मेरे को, मैंने इसके ऊपर बहुत बोला है, ये सब्जेक्ट पे, ये टॉपिक पे, कि जब हम दो टेक्निक्स को कंबाइन करते हैं हु आर टोटली कॉम्प्लीमेंट्री, तो कैसे कंबाइन हो जाती है। आई हैव मुझे इंटरेस्ट है इसमें बात करने के लिए। मेरे पास प्रेजेंटेशंस बने हुए हैं ऑन चैलेंजेस इन कंबाइनिंग सच टेक्निक्स। तो मैं आपको डिटेल में तो अभी नहीं बता पा रहा हूँ क्योंकि आई डोंट हैव एनीथिंग टू शो और प्रेजेंट, बट एक चीज मैं आपको आंसर जरूर दूंगा कि जब आपने मेरे से पूछा है कि देखिए इसमें बहुत चैलेंजेस होते हैं। चैलेंजेस में जैसे मैं एक हाईलाइट करता हूँ, सिंपल सी एक चीज, जब हम क्रोमेटोग्राफी को मास स्पेक्ट्रोमेट्री से कंबाइन करते हैं, तो एक मेजर चैलेंज ये आता है कि मास स्पेक्ट्रोमेट्री को नैनोग्राम में कुछ चाहिए और क्रोमेटोग्राफी में कंटिन्यूसली कोई चीज निकलती रहती है, तो उसको हमको डायरेक्टली अंदर ले जाना होता है। मास स्पेक्ट्रोमेट्री में वैक्यूम होता है। तो ये जो चैलेंजेस हैं, एक में से जब सैंपल दूसरे में जाता है, तो जो चैलेंजेस होते हैं वो हैं, दे आर देयर, बट you will be surprised to know कि majority of the challenges have been overcome. दूसरी चीज ये होती है कि क्रोमेटोग्राफी को हम 30 डिग्री सेंटीग्रेड पे कर लेते हैं और मास स्पेक्ट्रोमेट्री को हम 200 डिग्री पे भी ले जाते हैं, तब सैंपल का क्या होता होगा, इसको भी ओवरकम किया है। सो ये जो हाइफनेशन जो होता है, ये मतलब जो एक जो ब्रिज होता है बिटवीन, दिस इज वेरी इंपॉर्टेंट, दिस इज वेरी इंपॉर्टेंट। और उसमें with technology, with science, these challenges have been overcome. एक और एग्जांपल मैं बताता हूँ, जब आप लिक्विड क्रोमेटोग्राफी को एनएमआर से कंबाइन करते हो, अब एनएमआर में आप प्रोटोनेटेड सॉल्वेंट डाल ही नहीं सकते, और क्रोमेटोग्राफी में सब प्रोटोनेटेड है। तो जब एनएमआर में जाएगा तो उसी के पीक्स आएंगे। एनालाइट के तो पीक्स ही कब आएंगे, कैसे दिखेंगे? इसको भी ओवरकम किया गया है। और एनएमआर की सेंसिटिविटी बहुत कम होती है और क्रोमेटोग्राफी का तो कंटिन्यूस फ्लो होता है। तो जब सेंसिटिविटी बढ़ानी होती है तो या तो हम कंसंट्रेशन बढ़ाते हैं या फिर हम टाइम बढ़ाते हैं, समय बढ़ाते हैं, मतलब एनालिसिस का समय ज्यादा कर देते हैं। एनएमआर में अगर आपको पता है तो हम 500 स्कैन्स, 1000 स्कैन्स, 10,000 स्कैन्स, 20,000 स्कैन्स लेते हैं, तब हमें एक एनएमआर मिलता है। ये आपको शायद पता ना हो। अब ये क्यों लिया जाता है? क्योंकि जो भी न्यूक्लियाई हम स्टडी करते हैं उसका रिलेटिव अबंडेंस बहुत कम होता है, तो उसकी सेंसिटिविटी हमें बढ़ानी होती है। कॉन्सेंट्रेशन से बढ़ाते हैं अगर, तो उसकी जो सेल की जो कैपेसिटी है, मतलब जो प्रोब है उसकी कैपेसिटी है वो कम होती है, तो हम टाइम बढ़ाते हैं। अब क्रोमेटोग्राफी तो कंटिन्यूस प्रोसेस है, वो तो रुकती ही नहीं, तो इसलिए एक लूप सिस्टम डेवलप किया गया है जिसमें हम स्टोर करते हैं कंटिन्यूसली ड्यूरिंग सेपरेशन, और उसको बाद में हम स्टोर्ड को एनएमआर में डालते हैं, और वो भी इतना डालते हैं कि कंसंट्रेशन इतना हो जाए कि आपको एक सेंसिटिव एक सिग्नल दिखाई दे, वरना सिग्नल ही दिखाई देगा नहीं आपको एनएमआर में, क्योंकि हम या तो H1 करते हैं या C13 करते हैं या दूसरे आइसोटोप्स करते हैं, उनका कंसंट्रेशन बहुत कम है, रिलेटिव अबंडेंस बहुत कम है। इसलिए हमको ये जो चैलेंजेस हैं, ऐसे टेक्निकल चैलेंजेस हैं, इसको भी हम ओवरकम करते हैं। प्रोटोनेटेड सॉल्वेंट्स के भी हम बीच में हम एसपी लगा देते हैं, तो एसपी में प्री कॉन्सेंट्रेशन हो जाता है, मतलब कॉन्सेंट्रेशन बढ़ जाता है, और जो ड्यूटेरेटेड सॉल्वेंट्स यूज होते हैं वो कम यूज होते हैं। नहीं तो अगर ड्यूटेरेटेड सॉल्वेंट अगर हम डालेंगे क्रोमेटोग्राफी में, तो एक सैंपल की कीमत जो भी 500 रुपए है, वो एक सैंपल की कीमत 10 से 15,000 रुपए हो जाएगी। तो वो भी अवॉइड किया जाता है। हर चीज देखी जाती है, कॉस्ट भी देखी जाती है, टाइम भी देखा जाता है, इफिशिएंसी भी देखी जाती है, सेंसिटिविटी भी देखी जाती है। तो ये सारे बहुत ही टेक्निकल चैलेंजेस होते हैं। और आपने जैसे बताया, बहुत सही पॉइंट है कि इतनी डिफरिंग प्रिंसिपल्स पे वर्क करने वाले को अगर हम जोड़ते हैं तो प्रॉब्लम्स तो होती हैं। इसी वजह से क्या है, आज की तारीख में जो काम हो रहा है, तो अभी वो इतना ज़्यादा कॉमर्शियली उसकी वायबिलिटी है, बट इट इज़ नॉट, यू विल नॉट फाइंड इट एवरीवेयर, यू विल फाइंड इट एट फ्यू प्लेसेस, बिकॉज अफोर्डेबिलिटी भी होती है। विथ टाइम, with more technology, you will find that maybe 5 years from now you will find LCNMR in some of the labs. Now at the moment you don't find such instruments. There is an instrument called LCNMR MS, three techniques, three different techniques combined together. So that also is not seen, but it is functional. It is not operated here, it is operated in Europe, it is operated in Japan. Instruments have been made, but to make it more commercially viable, and just like HPLC, you need to do more research and bring down the cost of analysis to a level where it becomes more affordable. So yes, your question is very valid and very genuine, and I could give only a very small response to what you said. But yes, there are challenges. There are challenges. I hope I have give you some idea about this, Khushbu.
Yes, sir. Yes.
Okay. Anything else you want to ask? it is good that people ask something. I mean, this is very important. Learning में.
हेलो
हाँ कार्तिक.
लास्ट में
हाँ लास्ट में.
लास्ट क्वेश्चन है मेरा आपसे.
हाँ
सर जब हम किसी कंपनी का सैंपल एनालिसिस करते हैं right?
हाँ.
तो लास्ट का हमारा एक फॉर्म था कि हमें रिपोर्टिंग या डॉक्यूमेंटेशन करना रहता है right? तो कुछ कंपनी का एसओपी होता है, बट अगर हम कुछ रिसर्च करते हैं या मतलब कोई ऐसा सैंपल जिसका एसओपी नहीं है, तो उसमें क्या क्या चीज हमें कंसीडर करना रहेगा, मतलब वो करना ही पड़ेगा उसमें डॉक्यूमेंटेशन में.
देखो, तुम्हारा जो सवाल है वो थोड़ा स्पेसिफिक है. तुमने मेरे से ये कहा कि जब हम कंपनी में जाके काम करते हैं तो वहाँ पे एक एसओपी होती है, उसको हमें फॉलो
Yes.
करना है और उसी हिसाब से हमको रिजल्ट निकलता है और उसी हिसाब से हम रिजल्ट रिपोर्ट करते हैं और एक्सेप्टेबिलिटी होती है. तुम्हारा दूसरा सवाल था पार्ट कि जब हम रिसर्च करते हैं स्पेसिफिकली रिसर्च करते हैं, तब क्या ऐसा कोई फॉर्मेट होता है क्या? देखो, ऐसा कोई रिसर्च के अंदर कोई डेफिनेट फॉर्मेट नहीं होता, लेकिन कुछ चीजें होती हैं वो एसेंशियल होती हैं. वेदर यू वर्किंग इन अ फॉर्मेट और इन एनी सेटअप, कुछ चीजें तो आपको रिपोर्ट करनी ही होती हैं. जैसे कि अब आप रिसर्च में हो, आपने कोई नया मेथड बना लिया है या एग्जिस्टिंग मेथड को मॉडिफाई कर लिया है, तो आपको क्या करना होगा कि उसको आप वैलिड बनाओ. तो आप ये कर सकते हो कि उसको वैलिड बनाने के लिए, उसको सिग्निफिकेंट बनाने के लिए देयर आर सर्टेन थिंग्स विच आर वेल डॉक्यूमेंटेड. मतलब ये कोई नई चीज मैं नहीं बता रहा हूँ, दे आर वेल डॉक्यूमेंटेड. उसको तुमको तुम्हारे मेथड को उसको प्रूव करना होता है इन योर लैब, इन योर कंडीशंस. इट इज नॉट अ जीएलपी लैब, आपका रिसर्च लैब है, उसमें आप वो चीज प्रूव कर दो. प्रूव करने के बाद ऑफ कोर्स सब्सटैंशियल प्रूव करना पड़ता है. सब्सटैंशियली उसको प्रूव करना होता है through different techniques, through different methods, proving its significance, applying statistics, applying various validation parameters. आपको उसको प्रूव करना होता है. जब वो प्रूव हो जाता है तो आपने जैसे रिसर्च की, फिर आप उसको डॉक्यूमेंट करा सकते हो इन द फॉर्म ऑफ अ रिसर्च आर्टिकल. जब रिसर्च आर्टिकल हो जाता है, अब अगर वही प्रोसेस इंडस्ट्री लेती है, वही प्रोसेस या वही मेथड इंडस्ट्री लेती है, तो वो उसको अपने हिसाब से, अपने सेट ऑफ गाइडलाइंस के हिसाब से, अपने सेट ऑफ एसओपी के हिसाब से उसको प्रूव करती है. वहां पे उसको उस तरीके से प्रूव किया जाता है सो दैट इट बिकम्स एक्सेप्टेबल देयर. देखो, जो भी चीज इंडस्ट्री में आई है वो पहले रिसर्च के थ्रू ही आई है, इंडस्ट्री में आ गई है ऐसा नहीं है. जो भी चीज प्रूव्ड है वो सब रिसर्च से होके इंडस्ट्री में आती है. कोई भी रिसर्च करता है, जरूरी नहीं है कि मतलब इंडस्ट्री वाले रिसर्च नहीं करते, वो भी रिसर्च करते हैं पहले, बाद में उसको जब फॉर्मुलेट करते हैं, मतलब उसको रियली में एग्जीक्यूट करते हैं विथ रियल सैंपल्स, रियल प्रॉब्लम्स, देन दे वैलिडेट इट, देन दे फॉलो अ एसओपी. तो जो भी इसका जो तरीका है, मतलब जो आप रिसर्च करते हो उसको भी करने का एक तरीका है, उसका भी सेट ऑफ गाइडलाइंस है. जब आप कोई मेथड देते हो या बनाते हो या नया डेवलप करते हो या नया प्रोडक्ट बनाते हो फॉर एग्जांपल, तो उसके लिए भी सेट प्रोसेस है बिफोर इट गोज टू द इंडस्ट्री.
Okay, sir. Thank you.
वेलकम. वेलकम. Okay. Now, shall we end the meeting?
Yes, sir. Yes.
Okay.
Yes, sir.
Good.